This video is on the objective find the dot product of two vectors. So before I get to this question, and I'll say, I say this almost every video. If you want to see more about the topic, click on more instruction at the bottom of the question and you'll see, their videos. They might have some notes, some examples, read all that stuff, watch all that stuff, and hopefully those help you out. Now I'm actually going to show you some of those notes here. Finding the dot product of two vectors. Alright, so scalar multiplication involves multiplying a vector by a scalar, right? A vector by a number. And the result was another vector. When you multiplied a vector by a scalar, the result was another vector. If we multiply a vector by a vector, however, there are two possibilities. There's one vector product called the dot product, or the scalar product, and you'll see why in a second. And there's another one called the cross product, which we won't get into. Here, we will only examine the dot product. But like I said, you may encounter the cross product in more advanced math courses. Like if you go on and eventually get to Calculus 3, vector calculus, you will definitely run into the cross product. Alright, the dot product of two vectors involves multiplying two vectors together, and the result is a scalar. So when you perform this dot product of two vectors, your final answer will be a number, not a vector. It'll be a scalar. So here's a description of it. The dot product of two vectors, say vector v has components a and b, and vector u has components c and d, it's pretty simple to take. It is the sum of the product of the horizontal components and the product of the vertical components. And this is the notation for it. So v dot u. So I know it looks like the plain old multiplication symbol, but when these two multiplicands are vectors, this is called the dot product. So the dot product of v and u is again the product of the first components, a times c, plus the product of the second components, b times d. And then they show you an example here, very easy. The dot product of these two vectors would be negative 15 plus 48, which would be 33. And that's all you're asked to do. Now I'm going to go a little further in this video and explain what can you tell about two vectors when you know the dot product. Alright, so let's get to my problem here. Okay, so suppose we're given vectors u is negative I plus j, and v is I plus 9j. Find the dot product, u dot v. And again, your final answer will be a number. Alright, so what I'm going to do, go to a piece of paper here, and I'm going to draw these vectors. And there's a reason why I'm actually going to draw them. Alright, I want to point out something else about the dot product that wasn't mentioned here in their instruction. Alright, so there's x, y. Now vector u, they said it was negative I plus j, so negative 1 for the horizontal component, and then positive 1 for the vertical component. Now that's negative I plus j. So here's negative 1, 1. Right, if I'll draw it in standard position, starting from the origin. So starting from the origin, ending at negative 1, 1. There's vector u. Alright, and then vector v, they said was I plus 9j. So 1i plus 9j. Alright, so 1 for the horizontal component, 9 for the vertical component. So again, from the origin, that's 1 right and 9 up. Okay. And I'll draw this in a different color. So 1, 9. and from the origin to that point. Okay, there's vector v. Now, the dot product, what they call the dot product of these two vectors. So take vector u, then a big dot between them, vector v, and it's just the product of the horizontal components, so -1 times 1, plus the product of the vertical components, 1 times 9. Now this is simple. This is -1 plus 9, that's +8. And this is what they want us to enter. Notice again, the final result is a number, a scalar. Now, what I want to point out is the angle between the vectors. Now, if you look at it this way, look at this angle here. I'll call it theta. All right. Can you see how this is an acute angle? The angle between these vectors is definitely less than 90 degrees, is it not? All right. Well, that's something the dot product is going to be able to help you determine. I'll write this on another page. So, dot product. If the dot product of two vectors is positive, right, if the dot product is greater than 0, like this was, right, this one was greater than 0, 8, right? If the dot product of two vectors is positive, then the angle between them, if you were to have them start at the same initial point, the angle between them, you know, the not big one, I know there's technically two angles. There's the reflex angle, which is the large one. I'm talking about the smaller of the two. Okay. The angle between them will be acute, like in my previous example. Right, so you'll have, you know, vector u and, you know, vector v. Again, the angle between them is going to be acute if the dot product is positive. If the dot product of two vectors is negative, so say the dot product ends up being, you know, -1 or -13 or whatever, then the angle is going to be obtuse. Right, so bigger than 90 but less than 180. And I guess it could also be 180 degrees in this case, but it's going to be greater than 90 degrees for certain. So if you know, say this were vector u, and, you know, this were vector v, right, the angle between them is, you know, greater than 90 up to 180. Definitely obtuse. That's if the dot product is negative. And then the big important result that you'll come across in other courses, which again they're not mentioning here, but if the dot product is 0, you know, not greater than 0, not less than 0, but what if it is 0? Well, not acute, not obtuse, it'll be a right angle. It'll be a right angle, a 90-degree angle. So this is a very easy way to determine if two vectors are perpendicular in, you know, the xy plane. So if you see a vector like that, you know, say there's vector u, vector v, and they meet at a 90 degree. You know, if you were to draw them in this with the same initial point, they form a 90-degree angle. If that's happening, the dot product is 0. So that's a very quick and easy way to determine if two vectors are not perpendicular, right? So these two are definitely not perpendicular because their dot product is not 0. Okay? And the dot product is positive, right? And again, if the dot product is positive, the angle between them will be acute. If the dot product is negative, the angle between them will be obtuse. If the dot product is 0, the angle between them will be 90 degrees. Okay. All right, so I just wanted to point that out because I thought it would be interesting to know why you're learning this, right? Because really this is the last objective of this assignment, and all you're asked to do is find the dot product and not know why. I just wanted to give you one hint as to part of the reason why you're learning about the dot product. Okay, so back here, we're asked to enter our, again, the dot product was 8, right? The dot product was 8 between these two vectors, for these two vectors. Okay. Right. All right, so hopefully watching me do this, looking at the more instruction if you need to, reading the answer explanations when they come up. Right, I'm hoping all this stuff helps you when you're going about working on this material on your own. And thank you very much for watching.